Hello and welcome to part 2 of an introduction to radiation. Today we're going to look at alpha and beta particles and gamma waves. It shouldn't take long, but I will add some additional notes to the class notebook and to explain things in more detail. Let's get going and introduce you to an alpha particle. What we've got here is the nucleus of an atom. If you notice, the electrons are missing, so we only have the nucleus. That's why it's called nuclear radiation, because the radiation originates from the nucleus. And the electrons don't have any part to play in this process. If we click again, I think if you'd looked and noticed, an alpha particle, there it goes, consists of 2 blues and 2 greens. Not really that colour, okay, but the blues are represented by neutrons, and the little round green balls represent the protons. So when you see that an alpha particle consists of 2 protons, 2 neutrons, 2 blues, 2 greens, and you can see that what's left is a smaller nucleus. So when an alpha particle is emitted, the nucleus that's left is smaller. You've actually changed the element that you've got left. We can represent the alpha by an alpha symbol, and it consists of 2 p's and 2 n's. That's 2 protons and 2 neutrons. The symbol is therefore an alpha symbol, which is a Greek letter, 4 on the top, 2 on the bottom. Or we can say that it is a helium nucleus, 2 on the bottom, 4 on the top. Okay, that 4 represents the nucleons. It's called the mass number because that's where all the mass is. So it's 4 nucleons. And the nucleon is anything in the nucleus. So we know that in the nucleus is protons and neutrons. So the 4 is 4 bits from the nucleus. And the 2 gives us the number of protons. So you can obviously work out how many neutrons by taking the bottom number from the top number, and that will tell us how many neutrons we had. We can say it's a helium nucleus, okay, because if you look at a periodic table, any element with 2 protons is helium. But as there's no electrons associated with that alpha particle, it's not actually a helium atom. As we saw in the last week's video, it's a helium ion. So an alpha particle is actually a helium ion, or an ion of helium. Okay, and there goes another one, just because it's fun. Okay, so let's have a look at the beta particle. Okay, here's the beta particle. Sorry, here's your nucleus again. And just watch what happens when I reset this button. Look if the nucleus changes. See this blue here? Whoops. When a little red blob disappeared, that blue changed to a green. That's telling us that our neutron, the blue particle, changed to green, a proton. What was emitted was a red, and from the first screen and what we did last week, the red seems to be an electron, but we know that there aren't any electrons in the nucleus. So where does this electron come from? Well, you can see that it must be coming from when a neutron is changed into a proton, we release an electron, and that electron is a beta particle. It's not an electron from the outside of the nucleus in those shells. It is one that comes from the nucleus. The symbol for a beta particle is a Greek letter beta. Okay, and what we have is we have a neutron changing to a proton and releasing an electron or a beta particle. And you could see that. The number of nucleons hasn't changed. We've just converted one from being a neutron into a proton. And that's why we could also represent this as B for beta particles, which is an electron. And you can use the symbol, I often use E rather than beta, but it's nothing on the top because it doesn't change the number of nucleons, but it actually increases the proton number by 1, which is why we get a negative symbol. I'll go through that in more detail in the notes. So here's a gamma. If you notice, before that gamma was emitted, the nucleus was wobbling about. It actually has too much energy. And what happens with the with the gamma, is that unstable nucleus that has too much energy sort of burps and emits that extra energy. It's a bit like if we give you too much fizzy drinks, you all get high, you all run around, okay, until you've worn off that energy. There it goes, and it disappears. So here's me resetting. Another thing you can say is that these processes are random. You can't tell at any one moment where your particle is going to be emitted. It could go straight away, or it could take ages and ages. Gamma has a symbol gamma, okay? It's high energy radiation, and it's very strange because it doesn't have any mass. It doesn't have any charge, so it's quite difficult to detect. If you've done from your second year notes the electromagnetic spectrum, gamma is also part of that electromagnetic spectrum, so it's a bit like light and infrared radio waves. You can sing the song. And it is the only one that is in both of those groups. So you mustn't get confused with alpha, beta, gamma, which can talk ionizing radiation or nuclear radiation, with the electromagnetic spectrum. They do have something similar, but not totally. They all come from the nucleus. It is all random process. I had to record the script, so that's why it's a bit peculiar. So what have we learned? To sum it up, you should have known that nuclear radiation or ionizing radiation is random. You need to know the structure and symbols for alpha, beta particles and gamma radiation. Know their structure, symbol, and how they're produced, and what it does to the remaining nucleus when that happens. So I've put some notes in your class notebook. So if you go to class notebook, go under the radiation section. I don't seem to be able to scroll up for that, but you'll see there's some notes, and I'd like you to annotate this diagram. So put some labels on to show which is alpha, which is beta, which is gamma. You can also show and explain underneath what an alpha particle is, what a beta particle is, and what gamma radiation is, and I'd appreciate that. Okay, if you can put as much detail in there as possible. There's a few other things that I've added to that, and that would be really helpful. That's all I need to do today. As I've said, some of this is a bit tricky. You can get access to this little video thing in Flash Learning. All right, and you can take a note of these pictures. You can stop the video and go back and return, but please make sure there's a note in your class notebook. Thank you for listening, and I'll see you at the next video when you've completed that task.